The title of this note is Trig Identities, and the outcome is to be able to simplify and verify various trigonometric identities. There are several trigonometric identities, but the purpose of this note is to focus on those that you will have to have memorized for the midterm exam. So the first set of identities is for finding the sum of two angles. This is useful on the unit circle. So our unit circle, for example, only has 30 degrees, 45 degrees, and 60 degrees. Well, if I wanted to find 75 degrees, that's not on my unit circle. But what I could do is I could use two values that are on the unit circle. I could use 30 and 45 to make 75. So what I can do is I can split numbers into numbers that appear on the unit circle, and then I would apply these two formulas. So if I'm trying to find the sine of 75, I would use the formula sine A cosine B plus cosine A sine B, and that's multiplication happening there. For cosine, the formula is cosine A cosine B minus sine A sine B. The next set of identities that we have to have memorized are what are called the fundamental trig identities. These are grouped into different categories. So the first category are the reciprocal identities. And the most important reciprocal identities are cosecant and secant. And this actually already came up when we were graphing. Cosecant is equivalent to 1 over sine. Notice that sine, that's the guide function for cosecant. That's the reason it was the guide function. Secant is equivalent to 1 over cosine. Again, because cosine is the guide for secant. The next set of identities that we have to know are the quotient identities. There are two here. Tangent is equivalent to sine over cosine, and cotangent is equivalent to cosine over sine. Notice that tangent and cotangent are reciprocals of each other because sine is in the numerator, cosine is in the denominator, and then we flip it for cotangent. So there's a couple different ways to remember these. One of the ways that I remember is that cotangent starts with cosine. The other way I might remember is thinking about my unit circle. I know that on my unit circle, sine are my y values, cosine are my x values. And if I'm thinking about my unit circle, and I think about a point on the unit circle, that point has coordinates x, y. And if I were to draw a right triangle, where this angle right here is theta, this is x, this is y, and I wanted the tangent of theta. Remember from geometry that tangent is opposite over adjacent, and opposite from tangent is y, adjacent is x, so y over x. And then again, I see over here, I know that for my unit circle, all of the y coordinates are sine values, and all the x coordinates are cosine values. So that basic geometry can help you remember the tangent quotient identity. The next identity that we have to know is called the Pythagorean identity. And the Pythagorean identity says that sine squared plus cosine squared equals 1. And the reason this is true, it goes back to the unit circle. So I'm going to use the same picture right here. Remember that in the unit circle, every radius, the radius of the circle is 1. So if we look at that triangle, we have an x value, a y value, and the hypotenuse is 1. X is represented by cosine, y is represented by sine. So the Pythagorean theorem says that leg squared plus leg squared is hypotenuse squared, or you might have heard it a squared plus b squared equals c squared, where a and b are the sides, c is the hypotenuse. So following that, we get cosine squared, that's this side, plus sine squared, that's this side, equals the hypotenuse squared. And then simplifying, we know that 1 squared is 1, and we're left with cosine squared plus sine squared. And it doesn't matter which one you write first. Order of addition never matters. We're going to use these identities to verify a trig identity. So what I have here are some helpful hints for verifying, and then after you record the hints in your notes, I'm going to walk you through one example. So when you're verifying, there are two sides to the equation. One of them is probably more complicated than the other. So it's a good idea to start with the more complicated side of the equation. You are going to use your fundamental trig identities. Don't worry about sum and differences. We're not going to use that. Use your fundamental trig identities. Those are the ones that you just recorded in your notes. You're going to use any algebraic techniques, especially regarding fractions. One of the most helpful things from graphing is we practice dividing a fraction by a fraction. So for example, if I want to divide the number 4 by 2/3, what I do is I instead multiply 4 by the reciprocal. And I can think of 4 as 4 over 1, and I would get 12 over 2, which would equal 6. So that idea is going to be really helpful. It's a really easy algebraic technique that's going to come up over and over. If you ever get stuck, another strategy is to just convert everything into sine and cosine. And one of the most important things to remember that when we are verifying, we are not solving. So we cannot move things across the equal sign. So we cannot add something to both sides of the equation. That's how you solve equations in algebra, and we're not going to be solving anything. So it's very important that you do not perform operations on both sides of the equation. So we're going to use these hints to actually verify an identity. The identity that we're going to put in our notes is sine x times cotangent x equals cosine x. You are checking to make sure that that is true. You cannot, absolutely cannot cross the equal sign. So I'm going to draw a line here, and I cannot cross this line when I'm doing my work. You're going to start with the more complicated side. So here, the left side looks a little bit more complicated. I'm going to go back to the identities that I have in my notes. And I see that I have a rule for cotangent that will convert it into sines and cosines. That was another strategy. So I'm going to keep sine x, and I'm going to convert cotangent using the quotient identity into cosine x times sine x. And then I'm going to say, oh, I can simplify that. Think of sine x as being over 1. And I can multiply these. So I can multiply sine x times cosine x in the numerator, and the denominator 1 times sine x. That's just sine x. And then I notice that I can factor out a sine x. It occurs in both the numerator and the denominator. And when it cancels out, I get cosine x. And notice that that's what the right side is. So I did all of this without touching the right side, and I verified that the left side does simplify down to cosine x. So that's how a verification works. That is the end of our notes, and we are going to practice more with this verification when we come into class.